All right, in this lecture, we're going to talk about the sum and difference formulas for sine and cosine. All right. Now, I'm not going to go through the derivation of these formulas. There's a derivation in your book. It's a little long and involved. It involves the law of cosines and the distance formula, and you can take a look at it. It's interesting, but I don't. In the end, really, you're just going to be responsible for being able to use these formulas, not necessarily know where it came from. I usually do not like to give you formulas without some justification of where they came from, but in this case, I'm going to skip the derivation and um, and we're just going to use these formulas today. All right. So you get to reap the fruits of mathematics and just use it and not have to worry about where it came from. All right. So one of the ways we can use these formulas, let me see if I can keep this on the page, is to find exact answers for angles other than the angles that we know from the unit circle, right? The 30 degree, the 45 degree, and the 60 degree angle. We know exact answers or exact sine and cosine values for those angles. But something like 15 degrees, that's not on our unit circle. But we can use what we know from the unit circle and these sum and difference formulas to find the cosine of 15 degrees. Okay, because we can express the cosine of 15 degrees in a couple of different ways. A cosine of 15 degrees, 15 is 45 minus 30, right? And we know the 45 degree angle, we know the sine and cosine for 45 degrees, and we know the sine and cosine for 30 degrees. Another way we could do it, there's a couple different ways here, because 15 degrees is also 60 degrees minus 45 degrees. Okay, so either way, we can do this either way, and then we can use the sum and difference formulas, and the sine and cosine values for either 60 degrees and 45 degrees or 45 degrees and 30 degrees to figure out the exact value for the cosine of 15 degrees. So let's do that. So I'm just going to grab the first one. Cosine, let's do the cosine of 45 degrees minus 30 degrees. Okay, that'll give us the cosine of 15. All right, so let's take a look at what a formula we're going to use. It's a cosine, so it's going to be one of these second two, and it's a difference. So I'm going to use this one. All right. So in this case, my theta, this is theta, and this is phi. All right. So I'm just going to then substitute those values for theta and phi into the equation. So I have the cosine of theta, which is 45 degrees, times the cosine of phi, which is 30 degrees, and then plus, notice it's a plus, the sine of theta, which is 45 degrees, times the sine of 30 degrees, which is phi. Okay. Now I just need to use my unit circle and figure out what those cosine and sine values are for 45 and 30 degrees. So if I look at my unit circle, 45 degrees is right over here. We know that the sine and cosine are square root 2 over 2 comma square root 2 over 2, right? Those are the coordinates of that point. So let's substitute that in. So here we're going to get the square root of 2 over 2. And over here, we're going to get the square root of 2 over 2 for 45 degrees. Now we can also look at the unit circle and we can find 30 degrees. So 30 degrees is over here. The cosine, the x coordinate, is the square root 3 over 2. And the y coordinate is 1/2. Okay, so that's my cosine and my sine. So I'm going to substitute for cosine of 30 degrees, which is the x value, which should be the square root 3 over 2. I'm going to add to that this, I need the sine of 30 degrees, which is 1/2. All right, now it's just a little arithmetic to kind of put this all together. All right, so I'm going to multiply these two fractions, square root 2 over 2, square root 3 over 2. So I can multiply the numerators. I get the square root of 6, right? And then multiply the denominators, I get 4. And same way over here, I multiply the numerators, I get square root of 2, and the denominator is 4. So I can actually express that as one fraction if I want to. Now this is a fine answer right here, but I'm going to express this as one fraction, square root of 6 plus the square root of 2 all over 4. Okay. Now if I put that in my calculator, I get the decimal approximation is 0.9659. Okay, but that's not what I want. It's asking for exact answers. Now keep in mind too, remember your rules for exponents and how to work with these square roots. You cannot just put this under one square root. So the square root of 6 plus the square root of 2 is not the same thing as the square root of 8. So don't do that. Don't put everything under one radical. This is it. That's as good as you can get right there. That's the answer. All right. Well, that takes care of example 1, and I'll meet you for the next example.